In this video, we're going to look at another type of addition reaction called a hydration reaction. And we'll start by investigating what hydration is. So from the name, hydration is the addition of water across a double bond. If you look here, I've written water as HOH. That's because hydrogen will add to one carbon, so we'll call this carbon 1 of the double bond. And OH will add to the other, which we'll call carbon 2 of the double bond. All right, so we're going to go through the hydration of ethene, our simplest possible example, to just look at what this reaction looks like. So we start with ethene, 2 carbons with a double bond, and we add water. I'm going to write water in blue, and I'm going to write water for hydration reactions for now as HOH, so hydrogen hydroxide. That's going to help us just trace where each hydrogen and hydroxide came from. Hydration reactions are always done in the presence of an acid catalyst. So this is a strong acid. You don't need to know the anion or anything like that. We'll just write H+. And when we look at the mechanism a little bit later, you'll see why we need that acid catalyst. Okay, so we're not going to remove any atoms from our organic compounds, so we'll still keep our 2 carbons and our 4 hydrogens. However, we're going to break that double bond in the middle. And instead of having a double bond, each carbon will get a new single bond. And one carbon will get a hydrogen, and the other will get a hydroxide. So what we're forming here is an alcohol. The first example we're going to look at is the hydration of but2-ene. So we've drawn but2-ene here. It's a 4-member carbon chain with a double bond between carbons 2 and 3. And when we hydrate this, we're going to be adding water in the presence of a strong acid catalyst. So I'm going to put the water down below just so that we can kind of map on where everything is going to go. And I'm going to write the water as HOH. So above the arrow is a catalyst. So one hydrogen is going to go to a carbon of the double bond, and the OH will go to the other carbon of the double bond, so that they will end up on adjacent carbons in our product. So carbon 2 and 3 had the double bond. Carbons 2 and 3 will get our hydrogen and our hydroxide. And our product here is butan 2-ol. Our next example is going to be the hydration of pent1-ene. Our last example and our first reaction we looked at both had symmetrical molecules, meaning it didn't matter if we added the OH on a particular carbon. In this case, we're going to see that we can end up with multiple products when we have an asymmetrical molecule. So pent1-ene has a double bond between carbons 1 and 2 of a 5-carbon chain. And there are 2 options for where our OH group can go. The first option is that our hydroxide group can be placed onto the first carbon in our chain. If this is the case, then our product will be, so strong acid catalyst, our product will be a primary alcohol with the OH on carbon 1, and we're not going to draw the H, but it goes on carbon 2. This product would be pentan-1-ol. The other possibility is that our OH goes on to carbon number 2. If this is the case, we will have pentan-2-ol. So hydrogen on carbon 1, hydroxide on carbon 2. So pentan-2-ol. So in one scenario, we've made a primary alcohol. In the other, we've made a secondary. You do not need to know how to predict which is more likely. You just need to know that both can occur.